Hello friends, today we will gain knowledge about major contributions of Adanson, deCandolle and Hutchinson to plant systematics. And our main objectives will be to discuss contribution of Adanson to plant systematics, to discuss contribution of deCandolle to plant systematics, to discuss contribution of Hutchinson to plant systematics, to underline merits and demerits of Hutchinson's system of classification. So, first of all, we will discuss contribution of Adanson to plant systematics. Michael Adanson, a French naturalist, was born at Aix-en-Provence on 7th April 1727. His family moved to Paris on 1730. After completing the education at Collège Saint-Beuve, he was employed in the Jardin des Plantes, Paris. He attended lectures at the Jardin du Roi and the Collège Royal in Paris from 1741 to 1746. While he was cataloguing the plants that had been grown in the Jardin du Roi since 1740, Adanson began to think about the idea of a classification system capable of describing all living plants. He was determined to travel to some little-known region where he could discover new plants and used his connections to secure a position at the trading post in St. Louis, Senegal. Before leaving, he gave up his stipend and acquired the various skills required to collect data on the country's flora and fauna resources, population and geography. In the year 1748, he left France on an exploring expedition to Senegal, which was funded by the Compagnie des Indes. He returned with a large collection of plant specimens, some of which became part of the French royal collection, under the supervision of the naturalist Georges Buffon. Most of them now belong to the National Museum of Natural History in Paris. He published Histoire naturelle du Senegal in 1757, describing the flora of Senegal and a survey of molluscs. In 1761, Adanson was elected as foreign member of the Royal Society of London. In 1763, he published Families des Plantes in 2 volumes, recognized 58 natural orders based on their natural botanical relations. In this book, he proclaimed his contempt for systems and proposed a natural classification based upon all characters rather than upon a few arbitrarily selected ones, an attempt that brought him into conflict with Linnaeus. Recent historical studies have shown that Adanson's views were shared by many botanists and that he was responsible for the maintenance of Joseph Tonfort's system at the Jardin du Roi until 1774, when de Jousseau's system was adopted. Adanson owed much to Bernard de Jousseau's plant families as they were developed in his manuscript plan for the Trianon garden, in which he arranged the plants in beds in an order corresponding to his system of classification. He soon recognized that his Families des Plantes was only an outline of his general conception, and in 1769 he prepared a new edition that was never published. In 1759, while working with the Jousseaus on a manuscript plan for the gardens at Versailles, he completed his outline for the plant classification system that he originally conceived as a student in the Jardin du Roi. Families naturales des Plantes, published in 1763, owed much to the classification of plant families developed by Bernard de Jousseau for the flower beds at the Grand Trianon, and was inspired by the system of Joseph de Tonfort and by the empirical approach of John Ray. Adanson rejected previous classifications for their reliance on a few arbitrarily selected characters that do not apply to all plants. Instead, he proposed a system based on all characters, or rather 66 categories of characters, which when combined and united would permit the classification of all living plants, known and as yet unknown to science. Satisfied with the correctness of his method for botany, he resolved to apply it to the other branches of natural history and ultimately to all human knowledge, to create, in his words, a universal method. Although his Families naturales des Plantes was appreciated within the scientific community for its observations and discussions of family relationships, the classification system met with no success and was harshly criticized by the supporters of Linnaeus. But Adanson remained determined. Having contributed several articles on botanical subjects to the encyclopedia, Adanson began work on an encyclopedia of natural history based on his universal method. In 1774, Adanson submitted the French Academy of Sciences an immense work extending to all known beings and substances. It consisted of 27 large volumes of manuscript with the alphabetical arrangement of 40,000 species, a vocabulary containing 2 lakh words with their explanations, and a number of detached memoirs, 40,000 figures and 30,000 specimens of the 3 kingdoms of nature. The committee to which the inspection of this enormous work was entrusted strongly recommended Adanson to separate and publish all that was peculiarly his own, leaving out what was merely compilation. He rejected this advice and the huge work was never published. Adanson was an early proponent of the inheritance of acquired characters and a limited view of evolution. Historian of science Conway Zirkley has noted that Adanson was Lamarck's predecessor at the Jordan Royal, and Lamarck could hardly have remained unfamiliar with Adanson's publications. Adanson not only described evolution in his family's De Plantis, published in 1763 when Lamarck was a young man of 20, but also suggested that the changes in specific characteristics were produced through the inheritance of acquired characters. Adanson laid much emphasis on equal significance to all characters taken together. This is referred to as the Adansonian principle, which gave way to present-day numerical taxonomy. For this, he is known as father of numerical taxonomy. He rejected the earlier artificial systems of classification in favor of natural systems. He classified the plants using one character at a time, and he found that a large number of plants were always grouped together, irrespective of the character used. This led to the suggestion that a classification based on a large number of characters would reflect natural relationship. After having briefly discussion on our first objective, now let us go through our second objective, that is contribution of deCandolle to plant systematics. Augustin Pyramus deCandolle was born in Switzerland on 4th February 1778, educated and worked as professor of botany in Paris. Although deCandolle's main focus was botany, he also contributed to related fields such as phytogeography, agronomy, paleontology, medical botany, and economic botany. deCandolle's first book, Plantarum Historia Succulentarum, published in 1799, and Astragalogia, published in 1802, brought him to the notice of Georges Cuvier and Jean-Baptiste Lamarck. deCandolle, with Cuvier's approval, acted as deputy at the Collège de France in 1802. Lamarck entrusted him with the publication of the third edition of the Fleur franchise and in the introduction entitled Principes Elementaires de Botanique, deCandolle proposed a natural method of plant classification as opposed to the artificial linear method. The premise of deCandolle's method is that taxa do not fall along a linear scale, they are discrete, not continuous. In 1804, deCandolle published his Essai sur les properties médicales des plantes and was granted a Doctor of Medicine degree by the Medical Faculty of Paris. 2 years later, he published Synopsis Plantarum in Flora, Gallica Descriptarum. He coined the term taxonomy for the first time, meaning lawful arrangement of plants. His classical works include the book Théorie élémentaire de la botanique, published in 1813, in which he projected a morphological approach to classification. This also referred to the principles governing classification. From 1816 until his death, Augustin deCandolle worked in Geneva and undertook a monumental work intended to describe every known species of vascular plants under the title Prodromus Systematis Naturalis Regni Vegetabilis, the first volume appearing in 1824. He published 7 volumes himself. In this significant monographic work, deCandolle described all the plant species known at that time. Of the total 17 volumes, 7 were written and published by A.P. deCandolle himself. The remaining 10 volumes were written by his son Alphonse deCandolle and grandson Aimé Casimir deCandolle. Augustin deCandolle died on 9 September 1841 in Geneva after being sick for many years. The classification by A.P. deCandolle recognized 161 natural orders. The number was increased to 213 in the last revision of Theorie élémentaire de la botanique, edited by Alphonse in 1844, grouped primarily on the basis of the presence or absence of vascular structures. Ferns were provided a place coordinate with monocots, and in contrary to Dijosu, gymnosperms were given a place, although among dicots. The importance of anatomical features was highlighted and successfully employed in the classification. An outline of classification proposed by A.P. deCandolle in his Theorie élémentaire de la botanique is as vascularis, that includes vascular bundles present. Class first, exogene dicots. Diploclamidae, that includes thalamiflorae, calciflorae, coroliflorae. Monoclamidae. Class second, endogeny, includes phanerogamy, cryptogamy. Number second is cellularis, that includes plants with no vascular bundles. Class first, foliaceae, that includes mosses and liverworts. Class second, aphyllae, that includes algae, fungi and lichens. Dear students, with this we have reached to our third objective, that is contribution of Hutchinson to plant systematics. John Hutchinson was a British botanist associated with the Royal Botanical Gardens, Kew. Hutchinson first proposed his classification of angiosperms in his book The Families of Flowering Plants, the first volume on dicotyledons appearing in 1926 and the second on monocotyledons in 1934. The classification was revised periodically, second edition in 1959 and the third in 1973, 1 year after his demise. In addition to presenting his system of classification for angiosperms, Hutchinson also published valuable works such as Flora of West Tropical Africa, Common Wildflowers, A Botanist in South Africa, Evolution and Classification of Rhododendrons, British Flowering Plants, More Common Wildflowers, Uncommon Wildflowers, British Wildflowers, Evolution and Phylogeny of Flowering Plants, and Key to the Families of Flowering Plants of the World. Hutchinson also embarked upon an ambitious plan of revising genera plantarum of Bentham and Hooker under the title The Genera of Flowering Plants. Unfortunately, he could complete only 2 volumes of this work, published in 1964 and 1967, the project cut short by his demise. The classification system of Hutchinson dealt only with the flowering plants included under phylum Angiospermae as distinct from phylum Gymnospermae. The classification was based on 24 principles, including general principles relating to general structure of flowering plants and to flowers and fruits. These principles are outlined below. General principles. Evolution is both upwards and downwards. Evolution does not necessarily involve all the organs of a plant at the same time, and one organ or set of organs may be advancing while the other may be stationary or retrograding. Evolution has generally been consistent, and when a particular progression or retrogression has set in, it is persisted into the end of the phylum. Principles related to the general habit of plants. In certain groups, trees and shrubs are probably more primitive than herbs. Trees and shrubs are older than climbers, the latter habit having been acquired through a particular environment. Perennials are older than biennials, and from them annuals have been derived. Aquatic phanerogamous are as a rule more recent than terrestrial, and the same may be said of epiphytes, saprophytes and parasites. Principles related to the general structure of flowering plants. Plants with collateral vascular bundles arranged in a cylinder are more primitive in origin than those with scattered bundles, though it does not necessarily follow that the latter have been directly derived from the former. Spiral arrangement of leaves on the stem and of floral leaves precedes that of opposite and whorl types. As a rule, simple leaves precede compound leaves. Principles related to the flowers and fruits of plants. Bisexual flowers precede unisexual flowers, and the dioecious is probably more recent than the monoecious condition. Solitary flower is more primitive than the inflorescence. Spirally imbricate floral parts are more primitive than whorled and velvet. Many-parted flowers precede and the type with few parts follow from it, being accompanied by progressive sterilization of reproductive parts. Petalliferous flowers precede apetalous ones, the latter being the result of reduction. Free petals are more primitive than connate petals. Actinomorphy of flowers is an earlier type than zygomorphy. Hypogyny is the primitive structure and from it perigyny and epigyny were derived later. Free corpulus are more primitive and from them connate corpulus resulted. Many corpulus precede few corpulus. The endospermic seed with small embryo is primitive and the non-endospermic seed more recent. In primitive flowers, there are many stamens. In more advanced flowers, few stamens. Separate stamens precede connate stamens. Aggregate flowers are more recent than single flowers, and as a rule, the capsule precedes the drupe or berry. Following Bessay, Hutchinson considered flowering plants to be monophyletic, having evolved from the hypothetical Cycadidae ancestral group which he gave the name Proangiosperms. He recognized a number of smaller groups bound together by a combination of characters. He established Magnoliales as an order distinct from Rhineales, as he considered them to have evolved on parallel lines. Hutchinson regarded Magnoliaceae as the most primitive family of the living angiosperms. He considered dicotyledons to be more primitive and placed them before monocotyledons, giving them a rank of subphylum. The groups Polypetalae, Gamopetalae and Monoclamidae were totally abolished. Instead, Hutchinson recognized two evolutionary lines, division Lignosae and division Herbaceae, within dicotyledons. The former starting with Magnoliaceae and ending with Verbenaceae. The Herbaceae started with Peonaceae and ended with Lamiaceae. Within monocotyledons, he recognized three evolutionary lines, division Calliciferae, division Coroliferae and division Glumiflori. A total of 411 families are recognized, 342 in dicotyledons and 69 in monocotyledons. Lignosae includes 54 orders, Herbaceae 29, Calliciferae 12, Coroliferae 14 and Glumiflori 3. An outline of the system of classification of flowering plants presented by Hutchinson in third edition of the families of flowering plants is as: phylum first, Gymnospermi; phylum second, Angiospermi; subphylum first, Dicotyledons; division first, Lignosae, that includes 54 orders. Order first is Magnoliales, that is the first family Magnoliaceae, and order 54 is Verbenales, that is the last family Verbenaceae. Division second, Herbaceae, that includes 28 orders. Order 55, Rhineales, that is the first family Peonaceae. Order 82, Lamiales, that includes last family Lamiaceae. Subphylum second, Monocotyledons, division first, Calliciferae, that includes 12 orders. Order 83 is Butomales, that includes first family Butomaceae. Order 94 is Gingiberales, that includes last family Marantaceae. Division second, Coroliferae, that includes 14 orders. Order 95 is Liliales, that includes first family Liliaceae. Order 108 is Orchidales, that includes family Orchidaceae. Division third, Glumiflori, that includes 3 orders. Order 109 includes Juncales. Under this, there is single family, that is Juncaceae. Order 111 is Gramineales, that includes family Poaceae. Finally, let us deliberate our last objective, that is merits and demerits of Hutchinson's system of classification. First of all, let us discuss merits of Hutchinson's system of classification. The system of Hutchinson, being based on a number of sound phylogenetic principles and studies of a large number of plants at his disposal at Kew, shows the following improvements over earlier systems. The system is more phylogenetic than that of Engler and Prandtl, as it is based on phylogenetic principles generally recognized by most authors. The treatment of Magnoliales as the starting point in the evolutionary series of dicotyledons is in agreement with prevalent views. The abolition of polypetally, gamopetally, monoclamidy, orchiclamidy and metaclamidy, and rearrangement of taxa on the combination of characters and not one or a few characters as in earlier systems is more logical. Many large unnatural families have been split into smaller natural ones. Euphorbiaceae of Bentham and Hooker is split into two Euphorbiaceae, Racinaceae and Boxaceae. The family Urticaceae is similarly split into Urticaceae, Moraceae, Almaceae and Cannabinaceae. Standards of description are very high. Useful keys are provided for the identification of families. Phylograms for dicots and monocots are more superior to the Bayesian cactus. The classification of monocotyledons is sounder and generally appreciated. Even keys to the identification of genera have been provided. The derivation of monocotyledons from dicotyledons is widely agreed. The placement of elasmotales towards the beginning of monocotyledons finds general acceptance. Detailed classification up to the generic level together with the identification keys and description has been provided for some families in the 2 volumes of the genera of flowering plants. After merits, we will discuss demerits of Hutchinson's system of classification. The classification of Hutchinson has largely been ignored as it mostly did not proceed beyond family level and gave much importance to the habit. The major drawbacks of the system are listed as: the system is not useful for practical identification, arrangement in floras and herbaria, as it does not proceed beyond the family level in the greater majority of taxa. The division of dicotyledons into Lignosae and Herbaceae is most artificial and has resulted in separation of closely related families, Arielaceae and Apiaceae, in Lignosae and Herbaceae respectively. Similarly, Lamiaceae and Verbenaceae are very closely related and often placed in the same order in contemporary system of classification. Hutchinson, on the basis of habit, separated them under distinct orders and even separate divisions, Herbaceae and Lignosae respectively. Hutchinson did not provide a full explanation for the majority of his evolutionary concepts. He derives angiosperms from proangiosperms but does not provide information about the nature of this hypothetical ancestral group. Although he has split several large unnatural families into natural units, in some cases he has even split some families which were already natural monophyletic groups. The family Ranunculaceae has been split into Ranunculaceae and Heliboraceae on the basis of achene and follicle fruit respectively. Studies on the floral anatomy have shown that evolutionary stages in the reduction of ovule number can be seen in the genera of Heliboraceae, and many genera of Ranunculaceae show traces which would have gone to now aborted ovules. Thus, the Ranunculaceae of Bentham and Hooker represents a monophyletic group and need not be split. The family Chalcanthaceae is related to Laurels but placed here in Rosales. Hutchinson regards Magnoliaceae as the most primitive family of living dicotyledons, but most contemporary authors considered Vesselless Winteraceae or Paleoherbs be the most primitive. The monocotyledons are placed after dicotyledons, whereas the recent classifications place them between primitive angiosperms and the eudicots. Family Liliaceae of Hutchinson is a large unnatural assemblage which has been split into several smaller monophyletic families like Liliaceae, Alliaceae, Asparagaceae, Asphodelaceae in the recent classification of Jude et al., APG 2nd and Thorne. Dear students, this brings us to end of this lecture on major contributions of Adanson, deCandolle and Hutchinson to plant systematics. Hope you have enjoyed this lecture. Goodbye.